Okay. Yesterday we started talking about the rational zero theorem, and we talked about the P over Q, the factors of P over the factors of Q, and those are your possible rational zeros, okay? And then we did this problem right here. That took us quite a while, okay? And if you look at the next one, it's very similar to that one. And guess what? It's going to take quite a while too. So I think that for right now, we're going to go on. We're not going to do this example down here yet. We may go back to it later, but we've already done one like it. And remember, in the context of this problem, we were only concerned with the positives. Do y'all remember us talking about that? So we need to do some where it's more of a generic problem where we got to find all zeros, positive, negatives, and imaginary, okay? So go to example 3 on the next page. And now we're going to put everything together and we're going to find all the zeros. Put in the box, Brandon. So when I give you an assignment to do, I'm going to want to see all of this stuff. Okay? We're going to go through these right here. So we're going to follow it step by step as we try to find all the zeros. So example 3A. And I should have put those steps on this page too, but I didn't. So we'll have to flip back and forth. All right, f of x equals 2x to the 4th minus 5x cubed plus 20x squared minus 45x plus 18. All right. We look over here. To find all the zeros, you want to use the rational zero theorem to find the possible zeros. I should say possible rational zeros. All right, so this is the P over Q thing. So what's our P? 18. What's our Q? 2. Now remember, P is the constant. If you have everything in order from greatest to least, it'll be at the end. And then your leading coefficient will be at the beginning as long as the exponent's in order from greatest to least. So before you identify PQ, you want to make sure they're all in order. Okay, and of course here they are. So P over Q. Now what are mine? Remember, everything is positive or negative. What are my factors of 18?
1, 2, 3, 6, 9.
Okay, good. Y'all got them all. 1, 2, 3, 6, 9, 18. It's a little different than the one from yesterday with 8,019.
It's just silly.
All right. And then what are the factors of 2? Okay, so all of these are going to be plus or minus. Now, I'm not going to make you put the plus or minus in front of every single one of them. But they come in pairs. So if 1 is a possibility, so is negative 1. 2 is a possibility, so is negative 2. See what I'm saying? All right, so 1 over 1. 1. 1 over 2. 1/2. Positive or negative, don't forget. 2 over 1. 2. 2 over 2. 1, we already have it. 3 over 1. 3. 3 over 2. 3/2. 6 over 1. 6 over 2. We already have 3. 9 over 1. 9. 9 over 2. 9/2. 18 over 1. 18 over 2. 9, which is already there. So plus or minus 1, plus or minus 1/2, plus or minus 2, and so on. All right, but before we start trying them, we want to kind of have an idea of what maybe we need to start trying and narrow it down a little more by doing our, what's step 2? You don't have to use his name. You can just call it the rule of signs. So now we're going to do the rule of signs. All right, so let's count the ones in f of x first. So, yes, 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 yes. So, how many positive real? 4, 2, or 0. That's not extremely helpful because we could have up to 4, we could have none, okay? So maybe f of negative x will be a little bit better. So now, f of negative x is going to be, what signs are going to change? The odd exponent, the coefficients of the terms with odd exponents. Not odd coefficients, so don't get that in your mind. So the negative 5x cubed will now be positive, and the negative 45x will now be positive. So we have 2x to the 4th plus 5x cubed plus 20x squared plus 45x plus 18. Okay. Well, that's not terrible. That just means we don't need to try any negatives. Yeah. Well, I'm guessing there's going to probably be at least 2. All right. So 0, negative real. So we don't want to try any of the negatives. They're not going to work. All right, so now we're ready to do step 3. Test possible zeros using synthetic division. So where do y'all want to start? 1? I usually start with 1 or negative 1, but we're not worried about negatives here. So we have 1. Now, be sure if you need to mark that out, mark it out. Don't use those coefficients. Use the original. Are there any missing? That's not going to work. So what do y'all want to try next? I usually avoid the fractions until I have to. But. That one works, doesn't it? Y'all tell me if it goes off screen and I don't notice. Because if it goes off screen up here, it's going off screen on the video too. And I look over there periodically, but sometimes I don't pay close enough attention. All right, so now on this one, we want all zeros. Positive, negative, everything. So now we want to use our depressed polynomial. So 2 would be a coefficient of what? X what? X cubed, because you go down 1 from where you started. So x cubed, x squared, x. So 2x cubed minus x squared plus 18x minus 9. Now, it's not a quadratic, so we can't use quadratic formula. But since it's a cubic and we have 4 terms, we might be able to group rather than going back to synthetic division. So let's try grouping these 2 together and these 2 together. Of course, it'd be set equal to 0 if we're going to try to factor. So 2x cubed and x squared have an x squared in common. So factor that out, and you have a 2x minus 1, right? And then what can we factor out of 18x and 9? 9. Positive 9, and what do we have left? Minus 1. 9 over 9 would be 1. So that worked out good. Because now we can factor out a 2x minus 1 from these 2 terms. Now what do we do? Once we have it factored, we can set it equal to 0, right? So set each one of them equal to 0. So we have 2x minus 1 equals 0. Add 1 to both sides, so 2x equals 1. Divide both sides by 2. So x is equal to what? 1/2. So if you look up here, that was one of our possibilities. Now we do x squared plus 9. Now, you can't factor that. It's not a difference of squares. It's a sum of squares, and we don't have a way to factor that. So you can use quadratic formula, but since there's no middle term, you can move the constant over and then use square root property. So we'd subtract 9 from both sides, take the square root. So x would be, and it's always going to be plus or minus. Now, can somebody do the square root of negative 9 at one time, all at one time, without doing steps? What would it be? 3i, because square root of 9 is 3, and the square root of the negative would be I, the negative 1. So do we have all of our answers? How many should we have? It's going to, remember, the number of zeros is the same as your degree of the function, the original function. So it's a 4th degree function, so there should be 4. Do we have 4?
Yes.
What are they?
2, 1/2, plus 3i, -2i.
So 2, 1/2, 3i, and negative 3i. And I just put it up there because there's some blank space up there, and I'm trying to conserve room because we're going to have an example 3b. Okay, I'm going to back off this just a little bit. Okay. So now the next one, example 3b. F of x equals 9x to the 4th plus 5x squared minus 4. Yeah, here's what it said, try factoring and or quadratic formula, and we did factoring by grouping. I didn't flip back over a while ago. All right, so number 1, use rational zero theorem to find possible zeros. When you hear rational zero theorem, think P over Q. Okay. What's P? And what's Q? And you don't have to worry about the negative or the positive because it's all going to be positive or negative anyway. So P over Q. What's my factors of 4? 1, 2, and 4. And what's my factors of 9? Okay. So we have plus or minus. 1 over 1. 1. 1 over 3. 1/3. 1 over 9. 1/9. 2 over 1. 2 over 3. 2 over 9. 4 over 1. 4 over 3. 4 over 9. A lot of fractions there. All right, now what? Rule of signs, and make sure you check for positive and negative. So, and you don't have to insert missing terms or anything. You only do the worry about the missing terms for synthetic division. So we have no, yes, right? So 1, oh, that's good. Positive, real.
And it's going to be 0, negative.
So when we do, I'll put an f of negative x up here. Which signs are going to change? None of them, because there's no odd exponents. So it stays the same. So 1, negative, real. So we're going to have 1 of each. Okay, what do you want to try first? 1. Now, here's where you want to put, now be sure you go back to this one. You want to put in missing terms. So we've got a 9. Then our x cubed is missing, so we need to put a 0. Then we got a 5 for the x squared. Then our x is missing, so put a 0, and then a -4. One's not going to work.
It is 2.
Hmm?
It is 2.
All right, so she said 2 doesn't work. Well, you could try negatives because you know there's negative. Which one you want to try next? 4? And if y'all want to try different ones, and that way we can get it done quicker, that's fine.
It's just going to keep getting bigger.
Good. So you kind of start seeing you're getting further away. Yeah, that's not going to work because, yeah, it's just going to keep getting bigger. So, now what?
-1.
If somebody wants to try -2, go ahead. Oh, thank you.
Yeah, that works.
-1 works.
Yeah.
I didn't get it to work.
No, it doesn't because the 9 and 5 are both positive. So I just saw the 9 and 5 and thought one of them was negative.
Oh, I didn't put in my zeros.
Ah.
So never mind.
Did anybody already try -2? You're doing it right now? Now, I've already done it, so I know what works. But I like to go through it as if you were going through it. And when I do my notes on my own, I don't go straight to the answers. I go through the process like I would do if I were doing it without the answers, just like y'all would be doing. So, did anybody try -2 or -4?
I didn't get it to work.
-2.
It didn't work. It does. I can tell you right now, it doesn't work. -4 doesn't work either. I was going to tell you. So, guess what?
Fraction.
We got to start trying the fractions.
Mm-hmm.
So, which one you want to try first?
Did we have some fraction? 1/3?
Well, there, 1/2's not up there.
1/3.
Yeah, we've done fractions before.
Yeah, like in the very right when we learned it.
Yeah. All right, you want to try 1/3?
Yeah.
I would try the thirds first, then go back and try the ninths. I don't know why. So 1/3, 9, 0, 5, 0. At least we had these numbers to go by, I mean. And then if you want to put these in the calculator, you can.
Don't you do 9 times 3 divided by 1? Or is it 9 times 1 divided by 3?
9 times 1 divided by 3.
So we count
1/3's not going to work, is it?
1.
Because you end up with the fraction on the end. All right, let's try 2/3 then. Wait, I just did something wrong. Oh, I put 0 plus 6 is 4. Where did I get that?
Yeah, that works.
Now, to get your coefficients, remember you got to divide these by the denominator. And we had an x to the 4th, so this is going to be start with a cubed, right? So 3x cubed plus 2x squared plus 3x plus 2. So now what do we want to do? Set it equal to 0, and hopefully it will factor. So try grouping the first 2 and the second 2 together. And on the second one, you get 3x plus 2. We already have 3x plus 2 over here. So to get this number, you have to factor out a 1. Because you got to have a number to go with your x squared. So now you factor out a 3x plus 2. And then you have x squared plus 1. And once you have it factored, then you can set them equal to 0. Oops. Forgot about the negative. So how many roots are there altogether? 4. What are they?
2/3.
So let's see if that fits what we got over here. It said we were going to have 1 negative real. Yes. 1 positive real. Yes. So then the other 2, of course, had to be imaginary. Okay, you can flip over on the back. I'm going to give you 2 problems to do for practice. That's why I'm giving you 2 problems, not 10. So I want you to find all the zeros. Number 1, f of x equals x cubed plus 3x squared minus 25x plus 21. Number 2, f of x equals x to the 4th minus x cubed minus x squared minus x minus 2. Okay. Now, you're going to do those on your own, and we will check them. But I want everybody to promise not to look. Because for the video, I'm going to go ahead and put the answers up. So if you're watching the video and you want to try these, pause the video right here. And then when you turn it back on, the answers will be up there. Now, y'all don't look. Those of you that are sitting in my class.
It's on a different piece of paper, so I can look at that.
Yes, you can do it. Okay, I can turn this off now. So if you're watching the video, you may have to pause it. And just so you know, if you're watching the video, this is marked out because I didn't want to accidentally use these coefficients. I wanted to go back up and use the original when I did my synthetic division.